Okay, here we are. We're going to try and do some rational integrals. So remember, rational means that you have a numerator and a denominator, much like the problems we did in the last video with the inverse trig, but they're not going to be inverse trig problems. If you look at the two bullets I have here, it says if the degree of the numerator is greater than or equal to, if all right, more than the degree of the denominator. In other words, it's top heavy. You got more x's up top than you do on the bottom. And by that, I mean the exponents. The exponent up top is bigger than the exponent on the bottom. Then you have to use long division to split the problem up into smaller pieces. If the degree of the numerator is less than the degree of the denominator, in other words, it's bottom heavy, then you're going to have to use the process of completing the square to simplify the fraction. And I'm going to save that for another video. Okay, so we're just going to do 3 examples here. We're just going to do the long division. So we're focusing in just on this first bullet. All of the problems that we're going to do here are going to be top heavy or they're going to be equal. So the degree of the numerator is going to be more or equal to the degree of the denominator. Okay, so in this one we have the degree of the numerator is 2, the degree of the denominator is 1. So I'm going to use long division because there's no way I can split this up any other way. The top doesn't factor. It would be nice if the top could factor into x plus 2, x minus something, and then the x plus 2's can cancel, and then it's a really easy problem. But that's not going to happen here. So if factoring doesn't help you simplify the problem, then maybe it's a long division problem. So we're going to have to do long division. I don't know if you remember it from last year in pre-calc, but I'm going to do a problem here with you. We're going to put the x plus 2 on the outside. We're going to put the x squared minus x minus 5 on the inside. And remember, if there's any missing terms, then you have to fill them in with 0. Like if this was just x squared minus 5 on the top, you'd have to write x squared minus 0x minus 5 underneath. Okay, so now what we're going to do is we're going to take the first term in each piece. You have to ask yourself, what can I multiply x by to get an x squared? So what can x times what is x squared? And the answer, of course, is x. X times x is x squared. So I'm going to write 1x, and I'm going to keep all my like terms lined up. And now I multiply. So x times x is x squared. X times positive 2 is positive 2x. And remember, when we do long division, we subtract. And I'm going to go back to blue here. So x squared minus x squared is 0. That first term should always cancel. If it doesn't cancel, you did something wrong when you did your division. Negative 1x minus 2x is negative 3x. And then I'm going to bring down my next term, minus 5. Now I'm going to ask myself, I'm going to go back to this x, this first term, and now I'm going to work with this first term. What can I multiply x by to get negative 3x? So x times what is negative 3x? And the answer, of course, is negative 3. And now I'm going to multiply by the negative 3. So negative 3 times x is negative 3x. Negative 3 times positive 2 is negative 6. And I'm going to subtract. Negative 3x minus a negative 3x cancels. Negative 5 minus a negative 6 gives me positive 1. So that means that this problem can be rewritten as x minus 3 plus 1 over x plus 2. Because remember, when you do long division, whatever the remainder is gets put over top of what you're dividing by, the x plus 2 in this case. So I can rewrite, this is kind of getting junky here. I'm going to erase all this stuff. If you need to see it again, go back, pause the video and go back and you can see it. It's going for good for me, but it's not going for good for you because you can always rewind and go see it. I can't get all these little spaces. All right. So what I'm going to do, keeping in mind that this division problem is now equal to this, I'm going to rewrite this as the integral of x minus 3 plus 1 over x plus 2 dx. And then I'm going to split it up even further. I'm going to do the integral of x minus 3 dx plus the integral of 1 over x plus 2 dx. And now I'm going to attack these two integrals separately. I'm going to do this one on the left pretty easily. The antiderivative of x is x to the second divided by 2, or 1/2 x squared if you prefer to writing it like that. And the antiderivative of negative 3 is negative 3x. And I'm done with that first piece. I don't need to put the plus c there because I'm going to put the plus c at the very end when I'm done. This This other piece that I have dealing over here has stuff in the denominator, so I'm going to do a u substitution. I'm going to let u equal x plus 2. And as always, we need a du. So the derivative of x plus 2 is 1. So I get 1 dx. So this whole thing can be written as 1 over u, and dx can be replaced with du. So this becomes the integral of 1 over u du. And hopefully right now, bells are going off in your head, and you're like, wait a minute, I know the antiderivative of 1 over u. So I'm letting you see the next problem. I don't want to do that. So let me go to purple here. This is going to become, I like it 1/2 x squared minus 3x. Hopefully you remember that the integral of 1 over u is the natural log of the absolute value of u. But I'm going to go ahead and substitute my u in this step. So it's going to be plus the natural log of the absolute value of x plus 2. And I'm going to put my plus c on the end of the whole thing. That's what long division problems end up looking like. Okay, so let's do a second one. Remember, we're going to do 3 examples. If you want to try this yourself, pause the video and then try it. And if you get stuck, unpause it and see me working it through. And if you don't get stuck, you keep going, and then you can fast forward and see what the final answer is. All right, so let's do some long division. X minus 1 into 2x squared minus 3x plus 7. I'm going to do this long division a little bit faster. So x goes into 2x squared, 2x times. 2x times x is 2x squared. 2x times negative 1 is negative 2x. I'm going to subtract. 2x minus 2x, or 2x squared minus 2x squared is 0. Negative 3x minus a negative 3x is negative 1x. And I'm going to bring down the plus 7. X goes into negative x, negative 1 time. So negative 1 times x is negative 1x. Negative 1 times negative 1 is positive 1. I'm going to subtract. Negative x minus negative x is 0. 7 minus 1 is 6. So this can be written as the integral of 2x minus 1 plus the integral of 6 over x minus 1. I need a dx in here to be proper. Okay? So all I did is I took my answer, my 2x minus 1 is how I got this first integral. I took my remainder, divided it by my divisor, and that's how I got this second piece. All right, let's see what we got here. Let's go to, I'm going to go to red. So the antiderivative of 2x is x squared minus the antiderivative of 1 is x plus, I'm going to pull this 6 out. And I'm going to do my little u substitution up here. U is going to be x minus 1, and du is dx. So it's an even exchange. I don't have any numbers that I have to resolve. So this, the 6 is gone. So 1 over x minus 1 is 1 over u, and the dx is du. So my final answer is going to be x squared minus x plus 6, natural log of the absolute value of u, which is x minus 1, plus c. And that's your answer. Did you get it right? All right, one more example. Let's do this. I was supposed to leave 12 minutes ago. It's 3 o'clock on a Friday. And I was supposed to leave. Uh-oh, I can't see. There we go. And I'm still here trying to get this figured out. All right. Uh-oh. Houston, we have a problem. It's not top heavy. The degree of the top and the degree of the bottom are equal. Have no fear, you can still do long division. So here's how we're going to do it. We're going to put the x minus 1 on the outside. We're going to put the x plus 1 on the inside. And again, I do my division just like normal. X times what gives me x? Well, that would be a 1. So we'll put a 1 there. 1 times x is x. 1 times negative 1 is negative 1. And I'm going to subtract. X minus x is 0. 1 minus a negative 1 is 2. So this can be rewritten as the integral. I'm not going to split this one up yet. I'm going to write it all as 1. 1 plus my remainder 2 over my divisor, x minus 1 dx, which I can split up further. Oh, no, I've used blue already. Let's go green. I'm going to split this up into 1 dx, or just dx, plus, I'm going to pull the 2 out, 1 over x minus 1 dx. And hopefully you're starting to see a pattern here. Like this piece over here, this 1 over, usually ends up as a natural log. So let's do this. Let's go purple. The antiderivative of 1 dx is x plus 2. I'm just going to do a little u substitution here just to make sure I don't have any numbers to resolve. U equals x minus 1, du equals dx. Nope, no numbers that I have to divide out, so that's good. So this is going to become the natural log of the absolute value of u, which is x minus 1 plus c. And that's it. You now know how to do integrals with long division. The next step is completing the square. I might have to break that up into 2 mini videos for that as well. But I'm hoping that you're going to be able to do some of the practice problems that I'm going to give you on this.